So yeah, I was thinking like demoing this app first, which is a example app that we have like in the repository that is for a chatting app pretty much. Although it's focused more like on the backend, there is like a front-end client, but there is no like a whole web app, just a HTTP client that use the SDK. And so please feel free like to interrupt me at any time if anything doesn't make sense. But otherwise, I'll just keep going. And so this app here, you can see that it has two actors, one for the chat room and one for a moderator. And something that you can right away see is that each actor is divided into two files. The reason for that is that I wanted to separate the actor definition and the actor implementation. And I wanted them to be in separate files so that we would be able to import that on the browser, on the client, without also accidentally like importing like implementation details from the server. Quote is only for the server. And so if we first look at how we consume them, we have this file here, which is a file that would be like running on the browser, which is just a small effect program that we first initialize the clients. So we get the clients from chatroom the client. And you quickly see that the API from this has a lot of similarities from effect cluster. For anyone who's like familiar, like there's the effect cluster, there's like the entities. And I took a lot of inspiration from it because my goal was to pretty much build a SDK for a Rivet that was the most effect idiomatic, while at the same time trying to be within the meta model of Rivet. So there are some differences that you'll see later. There was also like another constraint, which was that we wanted to the SDK to wrap the existing Rivet TypeScript SDK. So it's built on top of it, such that it can reuse anything that's already built on the TypeScript SDK. And so due to that, like the implementation is also, like behind the scene, it's pretty different. But on the API level, I look at like other also actor model-like APIs, but the one from Cluster I thought was the most elegant one. So thank you first for anyone who has designed that effect, because it was very useful to help there.
All right, quick question.
Yeah.
Obviously, I don't have a lot of context on the internals of Rivet.
Mm-hmm.
I was curious if you evaluated an integration path where instead of building on top of the existing SDK, you'd have Rivet as the runtime for an effect cluster.
Mm.
I'm not sure if it's even possible. I was just curious if you investigated the direction at all.
I investigated, and from what I found, that was right at the beginning that I did. From what I found, it was not like possible, although I could be wrong on that. But I think the main constraint that like the Rivet, even like the Rivet TypeScript SDK, it has like an engine which is built on the with Rust. And Nathan, correct me if I said anything wrong. And that agent's like it's like runs with the SDK on the server, and on the client, I'm not sure if there's also like some like WASM code, or if it communicates directly with the backend. But at least on the backend, like the TypeScript SDK is pretty much a thin layer on top also of that Rust layer. Is that right, Nathan?
Yeah, that's correct. The client is just a lightweight TypeScript, which could probably be completely swapped to effect at some point. We're just trying to get like a V1 out because people have been clamoring for effect support. I'd be curious to explore cluster support more. We're like, effect has been a long story for us, where we shipped like a lazy effect wrapper. People are like, no, that's not good. I was like, okay, let's bring in something who's like really good at effect and put an aggro for this. And then we can look at what this looks like from here, because I'd be curious to see if I read.
But yeah, pretty much like all the network request goes through that Rust engine. So the SDK communicate with that Rust engine, and so we would need, I guess, to host that Yeah, I'm not sure if it would be possible like to bridge that, but maybe that's something you have to explore.
Yeah, the reason I'm asking was like in effect cluster, every piece is kind of modular, so you don't technically need to run our default implementation. And given that Rivet has the concept of actor/entity messaging and so on and so forth, I was wondering if the primitives there's good intersection enough for the primitives so that if you have a software that targets effect cluster, you can just deploy it on Rivet and that's it. But that's just my curiosity. And
yeah, I think there's also like the deployment story there for like Rivet. Like often you are the one hosting the code for like Rivet. Like you can even host like on Vercel functions. So that I'm not anymore sure. Nate probably could say more about this. Like it's not that you host the whole actors like in the on the Rivet infrastructure. Rivet is small, like a layer of your infrastructure.
Yeah. So we have like the Rivet engine or like the Rivet cloud if you're using the managed version. And that's what handles like the SQLite persistence for each actor. And then it handles like the network, like the addressable actors for each one has its own HTTP server. And then your code can either be on our cloud or it can bring your cloud, including serverless. And that's where each actor runs. I don't know it's been a long, I think I looked at like probably a year ago now at Effect Cluster to see like how that could be bridged. It's been too long, so I can't really say anything with confidence yet. I'll jump into James later and share some questions over just out of curiosity.
Yeah, we could explore maybe at the end if you have time, like to see how that could work. But yeah, my memory is also a bit fuzzy there. So continuing here, we have this effect program where we have a client that we get. So that would be for the chat room actor, and we get it by a key that we pass, and then we can see here that we can, using that client handler, you can call some specific actions. So that would be like equivalent to RPC on Effect Cluster. And here they call like action, and they're a bit more limited on what they do. And so they are more fit within like the existing Rivet meta model. And so then you can also, something that is like interesting is that the errors are kept end to end, and that's really thanks to effect here. And so you can see that this here room send message, you can see that it can error with like ban words error, which is an error defined into the code that we see later, and also Rivet error. And Rivet error, if we look into its file, it's like a error that has many different causes that map like to internal errors from the Rivet SDK. And so you can see here, actor not found, actor stopping, actor restarting. These are all different like causes within that higher level error. And so now with FXV4, this is like a new thing. You can do catch cause, and then we should be able to see all the type of error here.
Catch reason, maybe?
Oh, yeah, catch reason, sorry. And then we can see, wait, that's the wrong error. There you go. Then you can see like all the different reasons of how like an error can occur. And then some of them you might want to do. And if any like errors, then add in the future, but the SDK is not yet updated, that goes to like Rivet error with the reason of unknown error. So that's a pattern that you see also used on the AI, Effect AI like library. So I got inspired by that there. And then, yeah, we can see we send a message. And then we, let me just revert this. Then we send another one which like contains spam, and so that will create this error here, bandwidth error that we'll see later. And then at the end we just get history. And so I'm gonna leave it to later for me to run this. And now I'm just like gonna move into actually the server. And so first I'm gonna go into the entry point, where you can see here the first thing that we have is to put together like our layers. So construct like our layer graph. And so first you take all the different actor implementation layers. So we have here chat room and moderator live. If one of those layers use any custom defined service, so we have here room policy, we provide it to it. And then we also provide a client here because like an actor can communicate with another actor. And so we have to provide also the client for that actor. So in this case, it's moderate chat room communicates with moderator live. So he also needs a client layer. And then here we can see that we have a pattern that's similar to like how HTTP router and HTTP server works on the effect library. You have this registry.layer, which is responsible for collecting all the actors. So all actors register with that registry. And then we have registry.serve, which will just start a server, HTTP server, on your Node.js process. And that server is actually being run by the Rivet engine binary in the background. And layer launch here will then help us keep that alive. And we also have this to tear down on like on SIGINT and SIGTERM. And so that's similar as well to the APIs that we have on the effect library. And there is also another one here that is for when you're like within serverless environments. And if we now go into one of the actors, so the most interesting one is this one, the chat room. First, we have this file where I say we're like redefining the API. So we define custom errors, we define actions. Similar to RPCs, those have like a payload, success result, and also an error that you define through like effect schemas. Then at the end of it, you pass all those actions to the actor definition that you're creating. And then this actor definition can be important on the client, as we saw before here, to get a client. And it can also be used to actually do the implementation. And so in one of the previous office hour, we went a bit into this implementation. So there was some feedback that was suggested from this, which I'll address here. But first, let me just go walk through it again. So you can see here we have a custom service that I've defined with its implementation room policy live, and we are going to use that one within the actor implementation. And so to define the implementation, you have this two-layer method that you call in the chat room definition, and that accepts an effect which will be run every time that the actor wakes up. So when an actor is like not used, it goes to sleep. And then when it gets used again, it wakes up. And that effect here is executed every time that happens. And there is a scope associated with it, meaning that every time the actor sleeps, it then runs all the finalizers. And so we can see here there's a finalizer for like logging that this room is like sleeping. And from the get-go here at the top, you can see that we are able to yield some services. One is the address of the actor, which include the name, the actor ID, and the key. Another one here is our custom service that we have defined here. And so this then needs to be provided with a layer. And we can also, like at test time, we can provide like something that's like beautiful for testing. And we can also yield a client from like another actor, so that's like the moderator client. And the thing that is the most interesting is this state here parameter. So this is like the wake options object, and it includes like multiple things that you can use within your implementation. So At the moment, it only has the state, which is implemented with like effect idiomatic API. But in the future, we'll allow like for other APIs, such as like connections or like, I think there was another one, like the queue as well. So those are other things that can be available here. And this raw Rivet kit context pretty much is an escape hash that you can use. In the meantime, those API are not yet like implemented in the effect world. And so this state one here is pretty much a value that allows you to persist state and get that state. So that state is persisted across different wake-sleep cycles. And it is type safe, type constrained, because we at the end here are able to define a schema for that state and also provide an issue value. And so here there's like one feedback that was suggested, which does make a lot of sense, which is, would it make more sense to have this first into the API? Like first we define the schema and then we get then this function here, this effect here. And that's what I had at first. But the issue the reason why I put this like as a second parameter, it's because there can be like Rivet actors that don't have any option. So this is like a optional parameter that, like for instance, like an actor that doesn't have any state. And so that's why this is put like as a second parameter. Though it might be arguable, like maybe this is so rare that happens that it might be better to move this as a first parameter. But yeah, small tangent there. And then we can see that we can consume this state value very similarly to how we consume a subscription ref. We can set, update, modify, and more importantly, we can access state.changes, which is a stream over every committed state change for this actor. And this doesn't use a subscription ref in the behind the scenes because it communicates actually with the underlying Rivet TypeScript SDK, where we have like some hooks that we can use to get the changes. And so if for whatever reason, like the state is changed from like a different place than from the effect SDK, the changes will still come through here in the stream.
We also have a way for like our debugging API to actually modify actors on the fly. So that's also why this comes into help.
Yep.
Quick question. The lifetime of the actor is linked to every start and stop. So like whenever it hibernates, my finalizers will trigger, or is there anything more complex involved in tracking the states?
Every time it hibernates, that it sleeps, the finalizer will trigger, as you said.
Got it.
And then here you can see that you can leverage that to create like guards for like ensure member is part of like specific members of this chat room. And then here there's a preview of like the API for a feature API for like the queue, which is a concept that there is in Rivet. But I won't go into this yet because it's not yet implemented. And here at the end, pretty much you return all the implementation for each of your handlers. And so the one that's probably the most interesting here is the send message one. And so we can see that we use that guard that I just mentioned about, ensure member. That will use that room policy service that we declared above to make sure the user is part of that room. And if the user is not in the room, then it will return that error. And so we're able to leverage those things here to then get that error to the user at the end. And here we can also see that we are able to get like a specific moderator. So we're getting the moderator for our chat room. And then the moderator will review the message. And if the message containing like banned words, then we will fail this action with the banned words error, and that can be handled like on the browser. And here we can also see that we can still like use other APIs using like the escape hatch. So there is a DB API which uses SQLite, and so that uses here through like the escape hatch that we have here. And we're also able like to broadcast messages. That's also one of like the APIs from the escape hatch that's not yet modelized on the FX SDK.
Quick question: where is the SQLite storage running? Is it just a plain local file system? Does it go in the Rivet server?
So that Nathan, you will be able to answer.
Yeah, so that's part of the reason that our core engine is written in Rust is because we have a virtual file system for SQLite that gets persisted to the Rivet engine side. And so when you do a SQLite query, there's like it's almost like Neon for SQLite is what I like how I'd model it is like you can put a SQLite instance on your actor instantly and then start streaming data as you go. And we handle the whole persistence layer for you.
It's cool.
So I could imagine in the future, for example, wrapping that RivetKit context.db to get, for example, a plain like effect SQLite client, so that in the future could be even effectified even more.
Exactly.
I had a question about. We see that here that we have defined basically the handlers for each of the protocol messages that this actor can basically handle. I'm curious, what's the story for the concurrency of the execution of the handlers for the RivetKit engine? For example, I would imagine that I may have like two handlers attempting to write to the state. Is there somewhere to configure Rivet to say, for example, this handler can be run concurrently, this is only one at a time? Is it always one at a time? Just to know which is like the story for the concurrency in here.
Not yet. The way that we like to recommend doing this is kind of more like our traditional handler. We have something called a run handler where you can actually just like get a function call, and which is also great for effect. And then you can consume from like events, like our queue, for example. And then you can do that just a for loop and structure concurrently, however you want.
So actors currently are processing messages sequentially.
Sequentially, okay.
It's like that. The actions are actually in parallel, like sequentially in like the JavaScript runtime sense.
They're not serialized, or like they're not. They are concurrent, right? Yeah.
Like it's basically an HTTP call. It's like for each action, and then if you want to serialize it, you can either add your own thing or you can use like our run handler, which then you can just do like a while loop of like while give me next event, handle it, and then you just create back pressure on that next step.
All right. So now,
So just to understand that there is no ordering guarantee. If I send two messages to the same actor, the actor can receive them in the opposite order.
Oh, I see. Yeah. So that is there. That is handled by like the client. And so everything is serialized over the WebSocket. And then the way you send it for one client is the same order you get on the other end on the actor.
Okay. So for the same client, I get an ordering guarantee.
Okay. So if two different clients, for example, try to communicate with the same actor, there isn't ordering guarantee, but there is ordering guarantee per client. Just to explain that. Okay.
All right. I'm quickly just gonna show the moderator, but it's pretty simple. It's just that call that we had, a moderator.review, and just check if one of the words is part of the banned words. It also could be like a service here, a custom service. And then now I'll go just into the telemetry aspect of this, which also needed like to integrate in a way that made sense with the Rivet SDK. So the underlying Rivet TypeScript SDK allows you to pass a Pinot logger configuration. So there is pretty much like a logging base logger option where you pass this Pinot object here, and then you pass this option for Pinot. And so I needed a way where if someone would log something here in the SDK, so here I just like effect log here, it would like show in the same way than if something was logged within the TypeScript SDK. So that will be consistent. And the way that I modelize this is that first, by default, there is like a layer that is like a logger layer that is configured when you don't pass any layer, when the user don't pass any layer. But then your user can also pass like a custom layer configuration, passing like a Pinot configuration using this Rivet logger dot layer from Pinot. And then through that, you're able to provide that as a layer, and then that will configure both the effect SDK and the underlying Rivet TypeScript SDK to use that same Pinot configuration. And so now I think it would be a good time for me to just demo running this. So let me just switch the screen that I'm sharing, and let's go into the terminal. Okay, so now I'm just gonna start the server here, and we're gonna see that the RivetKit server is running. We get right away a log here, and that's configured with the log that I pass here. You can say I said like pretty, and that's why we have like the colorful log here. And then I'm gonna run the client, and you see pretty much every step that we had on that client file that we saw first. All right. So I run here the client, and you can see all the messages, all the logs for all interactions that we had. You can see also the errors that we logged. So it rejected non-member message. Mallory is not a member of this room. And there's also the logs that are coming right from the TypeScript, the underlying TypeScript SDK. You can see that they use the same logging configuration. And and at the end, like we pretty much make the room sleep, and that's how the program ends. And we also have here an example of like you can use the raw client from Rivet, and it still works with if you only have like the backend that is built with the FX SDK. So you can still interact with that raw client, and so you can do like an incremental migration if you're on Rivet TypeScript.
We have some Rust SDK, nice. Rust SDKs in other languages, so that also can place all well together.
Mm-hmm. How do you handle, I guess, type inference? In this case, it's TypeScript on both ends. Yep. So you might be able to derive it directly. I'm curious if your client is in Rust or other thing, how you get the types. But I guess this is
the TypeScript SDK, you mean, or here?
No, I think Nathan mentioned that this could also be a Rust client.
Yeah, no, we don't not like figured out automatic type generation yet, but okay. It's something people are asking for right now. We're like, we'll figure it out.
Yeah,
they will tell. Have you done anything with that with effect, like type bridging?
We are exploring, so we're building something internal where we do have Rust in the pipeline, and we need to do some type conversion between one side and the other. And we were kind of looking over different types of solutions. I don't think we have an answer yet, but it's something we're investigating. But that's the reason I asked. If you had something, I wanted to have a look at it offline.
No. On our like Rust API, we do a lot of generating JSON schema from our Rust types, and then we generate that back into, I can't remember if it's just type definitions or if we actually do this odd, but I'm curious to see what you come up with, because I figure that'll be cleaner.
The issue with that is that the JSON schema is fairly lossy. Like there's only a subset of things you can represent in JSON schema. So that's exactly what we did at the beginning, but we were not really satisfied. I feel like where we settled on was, okay, at some point we need to implement an actual generator of Rust code, but we haven't done that yet.
Well, I'll keep an eye out. I'll be happy to try it out.
And there was one last thing that I forgot to demo that I think you guys will appreciate, because that's also thanks to Effect. But of course, we get distributed telemetry tracing. And so for that program that we ran before, you can see here that we have this OpenTelemetry trace where you can see all the spans from both on the server and on the client. So this is the client side span, then there is one on the server, and then we see for the other actor on the client, and then the same other client but on the server. And you also get the errors that show there for like that specific span, the error there, and the events of the error. So that's all thanks to Effect telemetry that is embedded into it, which makes it really nice for someone that's not coming from Effect. Yeah.
And looks great.
Yeah. That looks nice indeed.
Yeah, otherwise there's still a lot of stuff like that can be implemented. First, like just implementing the other APIs that have not yet been implemented with Effect. Then there is also one suggestion that was done in the previous call, which was to instead of having the state be accessed as a parameter, to be something that the user yields. And actually, I need a solution with that today, but I'm still not yet convinced. Fully convinced is like the best path. There's some stuff that in terms of ergonomics that I'm not yet sure. But the idea is pretty much instead of like having the state as a parameter, you yield a custom state that the user defines previously. So yield the chat room state, and then this chat room state would then be provided as a layer higher up into the graph. The issues there is like if the user just yield the chat room state, how can I get like good errors that it shows the user still has to yield? And from my experimentation, I've still didn't achieve that fully. But there is a working version, but it's just the ergonomics not yet really, really good.
Makes sense. Just quick question around stability. Is using beta currently? Are you seeking feedbacks? Is the API stable enough to ship this in a production server? Against the scorpions, Igor was like, no.
No.
You know that by saying that tomorrow you will have something like 50 production users, right?
Our community does not listen to advice. I advise them multiple times not to use things, and they still use it.
I'll let you share more there.
Oh yeah, I mean the Rust has been like post 2.0 has been post 1.0 for a long time now. So the core infrastructure, like my understanding is the effect is like it's going to be like API stability, like things are still prone to change, like and there's still parts of the API that we're trying to effectively, like the database stuff definitely has been on our mind and stuff like that. But yeah, the core infrastructure, the Rust, like it's in production with a lot of folks already. Both on our Rivet cloud and on-prem. We do a lot of on-prem deployments too. So.
Yeah, for the Effect SDK, there is a lot of tests if you look into it. Also had fun with using the type tests, which I didn't use before, like with Vite. You can now test the types, or maybe it already exists for a long time, but I didn't know. So we have a lot of tests, but we haven't yet had enough like users for me to be able to say like it was confidently on production. Like it was released 2 weeks ago, and so just now I think people are like starting to use, and so. I would call that more like, I don't know how officially Nathan you guys call, but like either alpha or beta. That's pretty much the first users try to use this now, except me and the other tests that we have.
Just to clarify, this is wrapping your current SDK. So if Rivet on the server side is stable, if you use Effect, you're not going to break anything, and you always have the choice of okay, it's not stable enough for me. I can rewrite to plain TypeScript or Rust or whatever I like and keep that.
Yeah, it's just wrapping there. I'm using directly the TypeScript SDK. So the same APIs you would use is the ones I'm using behind the scene. Everything that is like public. I'm not going through like behind the scenes.
Not taking shortcuts with the server, basically.
Yeah.
It exposes the raw context, which is like a raw object. But everything there is actually a very thin call into Rust. So there's actually not a lot of JavaScript going on between the effect and our Rust engine, at least on the active side. The client side is all JavaScript. But on the server side, it's pretty thin between there.
Exactly.
It makes sense.
Yep.
Yeah, and some other things that could be improved, some ideas, is that improving like how testing can be done. Like for instance, I wish like there was a way for the user when they're like testing an actor that they could swap the state primitive that we expose to the user. So like they could put their own maybe a subscription ref there, or something later for like the database. At the moment, like it is not like easily swappable on the test side with like the effect APIs. But I think that definitely would be something that would be really nice to have. And it could be through like that exchange that you guys proposed. So that's the thing that
I was about to ask if, in fact, what is the testing story for the test, even with the plain Rivet SDK? You probably mock either the behavior or the entity, or you run the entity in memory and you attempt to run that. How's the testing story for Rivet right now?
On the engine side, or sorry, on the Rivet side, like the core Rivet, we literally run the full like Rivet cluster, in memory for you. So like we're if you're doing integration tests, you can like test the full thing confidently. And then there's layers below that, but we put a lot of work to make sure it's portable and really lightweight to run anywhere.
So basically, the story is keeping the runtime as thin as possible, so you can run it basically portable, whatever. And the testing story is basically running that thin runtime in memory or whatever you want to run that to test it with a real runtime.
We're a big, I think like you guys are a big fan of like libraries over SaaS. So like give everyone a TypeScript API, like let them do whatever, especially the agents, as opposed to like making everyone have to sign up for a service or like use some black box, thing to run everything.
And for the effect SDK, pretty much I have a test layer that provides a lot of the necessary service, similar to effect cross effect also has that, like a layer test. And I can and uses like the test engine pretty much.
That sounds nice.